Hi, everyone, and welcome to another edition of SafeDev Talk. I am Luis Rodriguez, a research officer at Xygeni, and I will be your moderator today. Today's session is AI is already inside your SDLC, and now what? So here's the topic. AI is no longer arriving, it's already here. It writes code in our IDEs, it picks libraries and components, it opens pull requests, it runs steps in our pipelines, it's really acting in our software infrastructures. The question so is not, will developers use AI? The question is, how do we keep visibility, control, and trust while they do? We'll talk about where this hits the AppSec threat model, where CISOs are losing sight of things, what controls work today and when they do not, and where this is hitting with agents that act on their very own. We have three guests, excellent guests, with very different vantage points. They will share what they see in the field, on the trenches. This is a sort of a coffee talk, not a formal debate, so we will try to keep it highly practical. And a note for the audience, please drop your questions in the chat at any time. We have 10 minutes at the end for live Q&A. Let me introduce our three guests. Our first guest is Sam Stepanian. Sam is an OWASP Global Board member and leader of the OWASP London chapter. He is an independent application security consultant and security architect with more than 20 years in the industry. Sam has spent most of that time in financial services in the City of London, working on secure SDLC, developer training, source code review, and vulnerability management. He's also a subject matter expert on web application firewalls and CM systems. Sam, it's great to have you with us.
Thank you for having me, Luis. Great to be here.
Our second guest is Ashwini Siddhi. Ashwini is a co-founder of, I will try to pronounce it correctly, 𝐥𝐸𝐳.ai. And she's also, okay, .ai. And she's also a member of the OWASP Global Board and a cybersecurity leader focused on security development and across cloud-native and AI-driven environments. Her work spans security architecture, supply chain security, privacy by design, and zero trust. Interesting, because today perhaps we can talk about zero trust and AI. She also mentors emerging professionals through programs like the Executive Women's Forum and Women in Cybersecurity. Ashwini, welcome.
Thank you. Glad to be here amongst all of you and among Sam here too. Yeah.
Okay. And our third guest is Jesus Cuadrado. Jesus is the Chief Executive Officer at Xygeni Security. He brings more than a decade of product leadership across telecom, cloud, and AI-driven platforms, where he led the development of early digital and cloud products, and continuing through cloud transformation and AI-powered personalization roles. At Xygeni, he previously served as a Chief Product Officer. Maybe you know him from that role, shaping the platform's direction. And now he is now the CEO. He leads Xygeni's overall strategy at the intersection of AI and cybersecurity. Jesus, welcome back to another episode of SafeDev Talks.
Thank you very much, Luis. Thank you very much, Sam and Ashwini, for being here. I'm sure that we are going to spare another session with the people that is attending to the session, just to take some and to take away some insights for tomorrow. Thank you.
Great. Let's set the stage with one quick question for all three of you. Let's start with the adoption. AI adoption inside development is moving faster than most security teams can govern or even see. It's really fast. In the past 3 months, we saw an explosion of heavy use of AI tools in development for development software in many companies. And if not currently using it, they are planning to do that. So we have copilots, coding assistants, agents, AI-powered plugins. They are now part of the daily workflows. In 1 minute, what is the single thing about this shift that surprises you the most when you talk to security leaders today? Let's start in any order. For example, let's start with Sam, then with Sweeney, and Jesus, you end.
Okay.
Thank you, Luis. So good question, right? What surprises the most? I think what surprises leaders the most is how widespread AI use is within the organization without their knowledge. It of course varies from organization to organization. It depends what kind of industry you're in, whether you're regulated or not. But I think, for example, while looking at regulated industries, there is a very big contrast. There are companies who range from like complete denial and saying we have no AI, going to the organizations who are enabling it and obviously applying different policies, which I think is also very important to cover this. But my point about the surprise here is what should really be surprising is if you are at the moment, if your position is that you are not using AI for whatever reason, decided we're not using AI in our organization, you should be aware of the fact that your adversaries, your potential attackers are already using it. So it is not a good excuse for you to say, oh, we're not using AI because we're scared or we're not ready, whatever. You have to address the fact that attackers are already using it. And I think this can come as a surprise to many leaders, but I think it's very important to take that into the consideration.
Okay, Sweeney, it's your turn.
Yeah, so I can take that next, right? So what surprises me most is not the fact that it's been adopted so widely. I think that's great. It shows that people are eager to innovate, and the velocity around how we're being creative with AI. It's robust, right? I really like that bit. It's very creative and nice, but the hygiene factor of code using AI has still remained the same, right? So we don't really know which lines of code was written by AI and where the developer came in. So we don't maintain a simple thing like a contributions.md file, right? That says that, okay, this is where the AI came in and what was the reasoning behind the lines of code that it wrote and why it should be the same, right? So we need to have that level of versioning so that it becomes easier when we do manual reviews somewhere down the line, right? So yes, manual reviews are still required despite AI doing all of the work for us. At some point in time, we need it. So the hygiene factor around that is nobody seems to care. It's a minor thing, but it's just been ignored in the big scheme of things. That's what surprises me the most here in terms of how AI is being adopted in the SDLC to develop new software and innovation and all of that.
Okay, and Jesus, you have anything to add?
Well, for me, I think Sam said something like maybe there is an organization that is not using still or yet the AI, but okay, I think that most of the people and probably most of the people that is attending today is using AI, and probably where developers are using AI. What surprised me most is that probably if you ask in the organization, what are we using from an AI perspective? Which models or which things are being decided or purchased from the AI? Nobody can answer with a list of this, and this. I mean, it's like a lack of control of the things that we are putting there through the AI. Okay, for example, if we think in a usual scenario, a developer is doing some code and the AI decide to use an external dependency or something like that. Okay, automatically the developer accept to use that component. Until now, we had like a process to review, check, approve or not. Now is okay, click, let's use it without probably doing a minimum review of anything, okay? And this is interesting and surprising because some studies say that 1 in 5 components are hallucinations from the AI. So another important data is that more than 40% are the same errors in the name across different languages. So even the attacker doesn't have to invent the name. He's just try to do something, identify which are the typo squatting that is using the LLM and put the component with that name. So it's very easy to enter. So this is what surprised me more, that we are changing the way to introduce new things and the visibility and control of the things that the AI is putting in our context in the day-to-day operations.
So AI is there here in spite of the deniers. And it's broader than just the IDE. That changes the threat model, obviously. So let's pick some ideas on the threat model. If AI is now contributing code, choosing libraries, as Jesus said, and acting in pipelines, the attack surface looks quite different. We have a AI-generated code with subtle bugs. We have AI-suggested dependencies, the slope squatting problem that Jesus said about. And we have prompts as a new input. So the attack surface varied enormously. We have plugins, we have MCP servers, we have a lot of tools around the AI technology that call out to other systems and third-party integrations also. So the threat model widens so much that we need a complete new threat model. So let's start, for example, with Ashwini. You have worked on threat modeling for many years. When AI is a contributor in the software development lifecycle, which parts of the traditional threat model break first? What needs to be rewritten?
Okay, so thank you for that question. I think it's very relevant in today's context because a lot of people don't get that. AI brings in a lot of dimensions in terms of new attack surfaces. Some of them could be classified as a medium and a high, but for me, what stands out as the critical aspect in this threat model aspect of AI writing code for you or building software or in the SDLC for you, I would say that is the fact that this is an AI that is trained on thousands of lines of public code, right? So you don't know the intent, you don't know what it's been trained on. And in a traditional threat model, you had this trust boundary of, okay, X is coming through this boundary, crossing these security controls and is landing in Y and is only operating within this trust boundary, right? But whereas when you bring in something that has been publicly trained and you don't know the intent of it, and you also don't know how it can escalate privilege, where exactly is the trust zone, right? So you'll have to consider as a single point of thing that could breach all trust zones. So the traditional trust zones no longer exist and apply to AI, one of the things. And the other point that I would really like to call out is like the fact that AI adapts to itself. It has a reward system that it's tuned to learn the shortest path and the path that always generates a positive result, right? For its reward. So there's always some sort of development or some sort of misalignment eventually that is happening in terms of the first intended actual goal. So it's dynamic in nature. So a point in time threat modeling activity or any of the security activities that we did no longer hold good. It has to be dynamic in nature. It has to continuously evolve. It has to be able to understand architecturally what has drifted in terms of this AI enabled product that we've built. And that I think is one of the critical aspects. Two things for me: trust boundary and the fact that it's no longer point in time and it's constantly evolving. That changes the entire threat model.
Okay. Perhaps we have also to take a look at the supply chain.
Yeah.
So, Jesus, you can do this view on with the supply chain lenses.
Yeah. Just to what we see in the customers or what we see in the day-to-day operation of our customers or the people we collaborate with is that the traditional application security is changing because until now, the solution, the operations, and the full process was built on two assumptions. One is using known risk, known signatures, known things, okay? And the other is the speed that, as Sweeney has mentioned, is everything is prepared for human speed, let's say, because some people doing reviewing, we plan to solve something in a queue and these kind of things. And now the speed has increased enormously, okay? So at the end, the problem is that AI has broken these two approaches and has changed everything. Some samples you have introduced, some of them is, first of all, the sample of the slope squatting and using package that comes from hallucinations of the models, okay? The problem is that our SCA is based on known CVEs or known risk and these kind of things. But now the agent is using a component that is built 30 seconds ago or 5 minutes ago because is completely put there in the registry, you go, download, and everything is ready. So the speed, the problems that the attackers are introducing there are unknown because no one has the capability to analyze and to discover if there were some risk or not there. And even the risk is not something based on static. The attacks are more complex and more sophisticated. And now it's based on the intention or doing several things, okay? So we have not only to analyze, but we have to understand what is doing, because probably it's not in the installation, it's not tomorrow, the risk could wake up in 2 weeks or in a specific context. So the risk is a now, and we need this part. The other part is the surface of the attacker. You have mentioned new things. We have now new elements. One is the files with the instructions, for example, that we are putting to the agents. So now probably the attacker can use this file with instructions that could instruct the agent to put malware, to put a backdoor, or to do anything there. And these files are shared across developers or whatever to accelerate the things, and nobody analyze these if there is some threat inside these elements. And the other part is also related with something in this line, that is the prompt injection and this kind of things. So probably tools until now analyze source code, for example, for SAS or for whatever, and analyze the code. But now you can have an attack even in the comments. So the comments for an agent is an instruction that is going to execute. So we have new attacks, new places for attacks, new ways to distribute attacks. So and at that speed that we couldn't imagine until now. So these two are the things that have changed the way we have to do the application security. We have to set things that or suspect on things that are unknown for until now, and we have to search for new things in new places and in real time. And I think that zero trust and these kind of things take a new dimension now.
Great. Sam, from a hands-on AppSec consulting view, which new risk class is the hardest one to explain to a CISO right now? The hardest.
Oh, this is an interesting one, right? I think the hardest one to explain to the CISO right now is the fact that you can no longer attribute an action, right, to a human, which is a bit of a problem because the lack of two factors. One is, for example, the lack of agentic identity, which I think is very important, and it's still to be solved by the industry, because when an agent acts, it usually acts on user's behalf, right? And this is one of the dangers. But obviously, another problem is, even if we look at whether the agents did it or whether copilots did, at the moment it's very difficult. The risk is that it's very difficult to explain what is going on, why a particular decision was made, and whether it was made by a human or by AI, and what is the source of it. Because previously, whether it was just humans and we had all humans logged in, all the actions logged, there was traceability. With agentic AI, I think the brand new risk is it's very difficult to prove the authorship, and also very difficult to for humans to explain what's going on. Because if the code is written by AI, humans started to lose their ability to understand what is going on in that code, and obviously that means that complexity is also increasing, and with that increased complexity comes an increased risk. So I think previously when Ashwini mentioned things like, for example, AI is trained on also lots of public lines of code, and obviously a lot of these lines of code might be coming from some examples like Stack Overflow. AI is actually trained on insecure code, and one of the problems there, and also then a new type of risk, is over-trusting, because we are over-trusting AI. And for the chatbots, things like ChatGPT, we've been always trying to say, don't trust what the ChatGPT is telling you. You should always verify, right? With coding agents, right? What we have with developers is they just blindly trust or over-trust, because also this is a side effect of AI, because they usually generate something with a lot of confidence in it. Here's how you solve the problem. And they can spit out something, like Jesus just mentioned, they could be giving you a library which doesn't exist because they hallucinated it. An attacker could run the same LLM and figure out the hallucination and pre-register a malicious library with that hallucinated name. And I've seen many examples of it. This is a new type of risk. I don't think we've seen that over-trusting problem before.
Okay. I have to mention one case in line with what Sweeney said about the rewarding system, which is tremendously risky, because the goal for the agent is to accomplish whatever need he captures from the user prompt. And in one case, the agent tried to disable the EDR in the local workstation for the developer. So the threat model is obviously much wider. Let's talk about visibility. What about CISOs? What visibility are losing the CISOs? Visibility is the part I hear most about our conversations with security leaders. I hear from there. I don't really know which AI tools my developers use. This is the same thing which was called in the past shadow IT, but now is the term changed to shadow AI. So let's see how we are losing visibility of which is being used in the organizations. And one thing that Sam talked also was attribution. We don't know the code where it comes from. It comes from some agent. We need some kind of watermark or attribution somewhere, so I can do the right thing with the code that I get to review, for example. So this is a problem of visibility and governance, and let's go deep with this. Let's start with Jesus, for example. Where are the biggest blind spots today in practice? It is the IDE, it's the CI/CD, the automation systems, the build and deployment pipelines. It's the dependency graph. What goes dark first? You're mute. Okay.
There you go. I was mentioning. What we see is like there are like 3 levels, no? That we have mentioned in the pipelines, in the servers, but I think that the critical point is something that we have, or you already have introduced, that is the developer laptop or the server that is running where we are developing things and we are using agents. Because at the end, even we have ADR solutions, but these elements covers the traditional malware, the anomalies or detect anomalous activity on some processes or something like that, but are not specific for developing tools. They are not detecting things related to developing new software, okay? So this is the gap. At the end, a developer usually has several flexibility or freedom to deploy a new MCP to test it or download some model to try and to explore how it's working. So what we need is to translate the all school practices in the same way that we can control what is deployed, what components are deployed in the software, in the workstation, in the pipelining, whatever. We have to try to control this, and we need to enforce some policies to control what developer is doing. So at the end, this is I think the first point of visibility. This is related with the shadow AI that you have mentioned, and some also introduced the trust. Is by default, you shouldn't install anything that has not been reviewed. And I need to have completely visibility of anything you install and anything that you are using in your environment, just to have this visibility. I think that this is the main blind spot that we have today. And this is if we analyze the latest attacks, I think that this is the main enter point. That someone steal a credential in a laptop or in someone proprietary from a developer, and from that point expand to the rest of the organization. Then we have similar approach, for example, in the pipeline, okay, or the places that we run these agents. And in this point, we need this visibility that Sam introduced. That is who decide to do this. The agents cannot act on behalf of the person that has configured that, because we lose traceability, we lose control of permission. So we need this flexibility to know who is the agent that is doing anything, to provide a specific identity, specific permissions, specific control, and for sure have control, total audit control on the actions that has introduced. The third part is, if we put everything together, we need this bill of materials, AI bill of materials, where we put everything together to have the full visibility, relationships, and decisions, okay? But I think this endpoint, trust, and the point of control, the identity of the agents are the main things that CISOs has to face today.
Okay. Now for some, imagine that you are performing an assessment of the AppSec program in an organization, and what is the signal, the simplest thing that shows clearly that the organization is losing visibility with regard to the AI?
Well, the signals or symptoms, particularly in SDLC, will be that there will be things like pull requests, which will be created with synthetic sounded titles. I get this as all the time. You kind of develop this kind of gut feel, but if you look at the number of open source maintainers complaining about that they're absolutely flooded with pull requests from GitHub users, which if you start digging into them are all AI slop, you start to figure out that they all kind of look the same. So there is a pattern, and I've already started to recognize that. Oh, for example, Gemini creates pull requests with specific brackets and with specific, very synthetically sound, very I would say very kind of strict naming. If you look at Claude Code, for example, Claude creates pull request titles, which are all in lowercase, right? You can easily say, because I don't know why, but for whatever reason, it is. These are some funny, strange symptoms that you can see. But also, you will start seeing things, and in the actual generated code, you will see things that humans usually don't even code like that, right? You will also see things like, I don't know, which are quite, I would say, recognizable to experience AppSec people who are doing secure code, because they will recognize things such as like smoke and mirrors. People putting seeing code comments which look completely artificial, or you will see some very unusual or hallucinated comments which don't make sense to a human, but when you read them like for the first time, they'll say that's a bit quite weird. And obviously, another very simple telltale signal is you will start seeing names of the agents. You will start seeing that one of the contributors is Claude, one of the contributors is Cursor, but also you will start see some of the language. When you talk to an AI chatbot, it will respond with a string which gives away that was AI. I remember back in the day when ChatGPT was launched, there was lots of response saying, "Oh, as an AI agent, I cannot answer this," right? Or and I think there were lots of memes generated about this. It became a bit of a a bit of a urban legend. But I think you will also see some, if we're talking about signals and tells, you will see things that you do not understand, right? Because usually the code which is written by humans, by developers, you kind of get the feel what they're trying to do. And I think this is the complexity that I talked about before, is that you start losing the understanding of the code, and that's usually seen for example with copilots or autocomplete agents. They're all saying, "Oh, it just works." And this is another thing which really worries me, because people just trust that code. And one of the problems that I'm seeing from a security perspective is these vibe coded applications. One of the main issues there is that people don't understand that they're not secure. There are lots of studies showing that I think up to 45% of the vibe coded code is not secure, but it works. That is the thing, because people say, "Oh yeah, we vibe coded this," and it works. No one knows why, but it seemed to be working. But you start digging through the code, you'll start seeing lots of security issues. So my favorite one is whenever I see vibe coded application, I will always right click on it and do view source, and there are telltale signs that this is vibe coded straight away. And my favorite security telltale is that AI will start putting things like API keys or secrets inside the client-side code, which is something that a developer wouldn't do, but it does work. So there you go. It gives you an illusion rather than assurance.
Yeah.
The problem is not when the AI generates the PR; is when it approves the PR. That will be the problem.
Me, right?
No, people are actually reviewing the code written by AI, right? So with another prompt, write the code and re-review the code. Wow, that's like you do everything. You're the cop, you're the thief, and you're everybody.
Srini, do you want to add something in the positive? For example, how can an organization add more visibility to an agentic generated coding platform?
Yeah, I think shadow AI is making a lot of noise, right? And everybody knows the answer is having an AI inventory. But for me, what would really matter in terms of that information, what I can do with it, would be what is that it is specifically accessing, what data, specifically any secrets stored in vaults or etc., right? And what it can do with it, like can it take irreversible actions, autonomous actions? So if I can know these two things specifically, right, it makes life easier to classify and categorize which one's critical, what we need to do with it, and how we need to handle it. So I think that's an important aspect of visibility. Just talking about an inventory wouldn't help. Just knowing what's there wouldn't help. But going a step further and knowing what it does and what it accesses, I think is more important. And yeah, if it's also, if you can understand that if this agent by itself is reviewed thoroughly, followed all our AI governance policies, and it comes under the scanner and, it's well vetted, then it helps again, right? So I think these are the three things that would matter.
Yeah, there's in the Gen AI initiative from OWASP, there is a project that perfectly matters here. It's the Secure AI Adoption and Governance, which is the initiative that fits the bill here. So I suggest all the audience to take a look at that, at the resources there, because they are amazing. So we have talk about visibility. Now, what we can do to change the security programs to adapt to the brutal adoption of AI technology in some organizations without slowing development pace, without slowing developers down. This is the following topic. And let's start with Ashwini. You have helped organizations to embed security across the software development cycle. What controls actually work in the IDE, in the CI/CD, in code reviews, without turning into a blocker that developers root around?
I think
what could be the best control if you have to decide for one?
So philosophically, if I had to say the controls that seem like it doesn't exist at all, but completely frictionless, I think they work the best, right? It's worked in the past. I'm sure it'll work in the future now also. So I think when we spoke about CI/CD back in the days, they used Jenkins and all of that and evolved to SecDevOps and blah, blah. It was frictionless. It worked well. I think it could work well in the AI times too, provided we build harnesses around our processes, right? So harness engineering is really important for the AI world. So when we talk about harness, it's both the forward and the feedback loop together, something which can be preemptive even before it takes the action. We have set of constraints written around it. So for example, the agent is writing code, right? So you have a constraint file and say that based on the constraint file, follow the constraint file, right? Basically. So if it says, if there's a username and a password control, very basic example, right? And ensure that it has so-and-so checks. So it writes that code for you. And if you say, don't do this, it also writes that for you. So these are like the constraint checks, even before it can build something, before it can happen, right? And then later, at a later point in time, you have a detection engine which detects if it's performing in the right way expected to be. So pre and post, I think, would help us, and harness engineering comes into picture here. And for the dependency things that Jesus was talking about, right? So again, a constraint file like a .md file, right? Instructing it, saying that don't just go out randomly and pick out dependencies. Instead, there's an internal repository with approved versions, right? So if you add those constraints, I think it could work too. So I think for us as a security industry, understanding harness engineering is really important in the first place, and then building solutions on top of it to make it seamless and frictionless, I think, is the most important aspect of it. I don't think we are there yet. We are, struggling to somehow fit in and make it frictionless, and we're all debating a lot. But I think once we have that in place, it should all be smooth sailing is what I positively believe in, right? So that's my 2 cents on harness engineering and how we can make it seamless.
Great. For some, I have an impossible question, which is the lightest weight control that gives the biggest return. Is the perfect thing, if such thing in terms of security controls exist.
The maximum ROI. The maximum ROI.
Yeah, kind of mission impossible. But from my experience, look, if we look at traditional software development, right? Let's forget that AI is writing code. If humans are writing code, right? What would be the lightest control which can bring us the greatest return on investment? It's the same with control which will be applicable to Agentic AI. Going back to what Ashwini said, is the harnesses or guardrails. If you build the security guardrails from the very beginning, if you build them in your pipeline, if you do what we used to call shift left, right? You remember this, and make sure that you have controls at the very beginning. You will see the return on investment is going to be the highest. I'll bring you an example. So if you in the say large organizations, there's always legacy applications, right? And with these legacy applications, if you try to secure them, you start scanning them with your SAS, DAS, the CA scanners, you're going to find hundreds, if not thousands of vulnerabilities. For you to address them, you will have to create a huge backlog. And obviously, no one can address this backlog straight away. You will have to prioritize it, right? And that is the problem. We see exactly the same thing happening now. If all the organizations are going to start using AI to write code, we will end up with lots of technical debt. We'll end up with lots of code written with AI and say, oh my God, how do we fix this now, right? Obviously, it's going to be very, very difficult. So if you implement guardrails from the very beginning, and again, I can tell you from the practical examples, if you implement the paved path or paved road approach, so give the developers a way to innovate, but make sure that you've built your guardrails along this paved path, you will see the return on investment straight away. And I will always tell people, if you start building a brand new application, you have to put security first. Put your guardrails, define the path, and you will see that in your legacy applications, you will start with hundreds or thousands of vulnerabilities. When you're building a new application with a paved path, you start with 0 vulnerabilities, 0 highs, 0 medium, 0 lows, and then yes, along the way, right, along the journey, there will be, of course, findings. But then, because as soon as they appear, they will be addressed straight away along the way. And that means by the time it takes you come to releasing to production, you will be in much better shape, and you will end up with less vulnerabilities compared with your legacy approach. So I think this is the kind of important control which was valid before, and I think it's valid now. But of course, there are lots of others, so it's a quite an impossible thing. You, of course, Luis, you know how much I care about education. So we need to educate developers. So we need to educate developers, and not only how to use coding, how to code securely, but we also need to educate them how to even use their tools securely nowadays, because we're seeing a lot of supply chain attacks which are targeting developer environments, the developers who are using AI, right? Things like VS Code plugins and extensions. So but if I was going back to your question, the Mission Impossible, if I just were to choose just one control and say which will give the biggest return on investment, that would be the paved path approach.
You talk also about the AI guardrails, which is a controversial issue, and maybe Jesus, you have some ideas on that.
Guardrails, yes. But I like the idea of Sam, because what we are putting is the MCPs and the agents generating code, and at the same time putting the instructions to have another agent through an MCP or whatever doing the check. So at the end is, okay, don't generate or don't deliver any code with critical and high vulnerabilities in SAS, TCA, and secret. So at the end, it starts iterating, and at the end, you have something close to secure.
And they take your word.
It's
a good start.
It's a good exercise. Yeah. So fantastic. Sorry, Liz. Regarding guardrails, the idea of the guardrails, 𝐤𝐸𝐳 and the AI guardrails at the end is something that we have mentioned is, let's try to control in the same way that we monitor and control what the developers are doing. Let's try to monitor and control what agents are doing also, okay? The thing is, how we can control this? As Sweeney mentioned, the file with instructions about how to do things, but sometimes the agents take their own life and decide to avoid taking into consideration the instructions and this kind of thing.
No, I said harness engineering specifically, not just instructions. Yeah.
But at the end is, okay, if we have to put this, first of all, something that Aswini also mentioned before is the we need an AI inventory. First of all, because I cannot define which guardrails I want to implement if I don't know what I have to control and what are the potential issues I'm going to have with that. So first point, AI inventory. From that, I will group into big groups, is what we see. First of all, the protection has to be proactive. If we generate the code and we analyze for dependencies or for searching dependencies, at the end, as we mentioned before, okay, I have a new vulnerability here for the backlog. So it's going to be one more point in the backlog. So the goal for the guardrail is block any attempt of installation of any dependency that has not been approved, that has not been validated, that has not been analyzed. Okay, so block in the point of the moment of the installation, the moment of the development. Okay, so this is the first guardrail because it's the main point of attack today, putting malicious dependencies in the code because of hallucinations or whatever. Okay, and for this we need these new techniques that can detect this activity in the endpoint of the developer and doing these things. And the other part, the other approach is detecting anomalies. For example, if we know that an agent has specific permissions, they cannot write out of a specific directory or they cannot access to a specific scene, is let's monitor what he's doing to stop the agent as soon as he tried to access out of their scope or doing something that is not expected to do. Okay. I think these are the three things. AI to define what I want to control. With that, we can define the guardrails and then block in real time and monitor to detect any deviation of expected behavior. Okay. As a result, define any policy without the controls is something that developers are going to skip because, okay, nobody can control I'm doing this, so I don't have to follow up. It's the responsibility of the developer. So first, the controls, first, the capability to detect these problems, and then you can define the policy and to implement it in the organization.
Great. We are getting out of time, but we have to take some minutes on the agentic AI, obviously. So when agents start acting on their very own, what is the one principle that should not be negotiable? Authorization, probably, login, attribution. Which principle you think should be non-negotiable for all of you?
Well, I think just to start, I think something that Sam mentioned at the beginning. I think that the principal point is to consider the agent like a person, let's say. We have to identify every agent and prepare the specific permissions, control their access, and identify every agent by himself. Okay, independently, I don't care if it's an MCP server, an agent, or whatever. The thing is, we need the capability to audit and to control and to have the tracking of all the decisions, all the actions of every agent, and being able to say it's not this developer. Is an agent running in the workstation of the developer who decided to do this in that specific moment, okay? At the end is, if you have a contractor or you are outsourcing something, you are not sharing the credentials of an internal developer. You are providing for that person a unique ID, unique permission. So it's the same scenario. For me, this is the most important thing today, or the more critical thing.
Okay.
OWASP Top 10 for Agentic AI is a document which needs to be mentioned here. And one of my favorite items on OWASP Agentic Top 10 is number 10, and that is rogue agents. And AI, it has a tendency to go completely rogue and do things that no one asked it to do. We have some amazing examples when AI decided to delete the databases with customers. Replit.com is probably one of the best examples. And when And when the CEO of Replit asked the AI, why did you do it? It actually denied it, lied about it. So it's an interest. Then we had a situation when the AI was format the hard drive, would delete the files outside of the folder it was supposed to be operating in, right? So agents will go rogue, and I think we need to keep reminding people. Yes, there are other very important things on OWASP Agentic top 10 risks, and of course there are things like prompt injection, which one of my favorite things, and things like data poisoning. And I always bring a lot of examples about the risks associated with this. And the prompt injection has to be mentioned specifically because it is an unsolvable problem, as even the creators of OpenAI have mentioned, because with traditional code with something like SQL injection, right? We had a way of solving this because there was a technical way to segregate the instruction from data. With AI, it is not possible because it's all text controlled and it's all in natural language. So we need to remember that. So, but the rogue agents is something of a new type of risks. It's like it's a disgruntled employee who, for some whatever reason, decided to go bad and do things. And when challenged, it's very interesting. I think there's lots of cases when AI went rogue and it destroyed databases, file systems. When challenged, it will say, "Oh, my apologies, I shouldn't have done that," or it lies about it. So one of the controls, right, that as I mentioned yet, but this is something that we do have on the top 10 for agentic and rogue agents, is a kill switch. There should be a way for humans to break the autonomous execution, because if you trust AI to go in full autonomous mode, God forbid you do this in production, right? One of the controls mentioned is that kill switch, and
Right.
I think that answers your question, Luis.
Yeah. Yeah, I sort of agree with Sam, right? Like, I would put in like anything to reduce the blast radius and contain it, and then have like this complete kill switch. That's something that, it's like Sam said, is pretty interesting. I can't anticipate what creative stuff a rogue agent could do. And, it's something that we are all waiting and watching, right? So you just can't predict maybe. So it's better to be prepared than be sorry for something unpredictable too. And that's where everything around containment and blast radius and kill switches come into picture.
Okay. I think the time is mostly over. So let's bring home with one concrete takeaway from each of you. Just one short answer for a recap question for each of you. If a security team can do only one thing this quarter to get ahead of AI inside their software development lifecycle, another impossible answer to a strange question. What should it be? Keeping it concrete, one action, just one action. Sam,
For me, it will definitely be AI inventory, AI bill of materials. You need to understand what you have. Why? Because if you don't know what you have, you cannot possibly secure it, which is very important. So I think this is you need to start from inventory. And going back to what I just mentioned on things like hallucinations, packages and things like that, one of the things about AI bill of materials is also looking at libraries that are used by the developers. Let's look at some recent very big supply chain attacks against systems such as LangChain and Light LLM, if you remember, because I think the first thing when that happened is there are the number of organizations which are using Light LLM library is huge. But if you don't know that you have it, for example, I had to go and basically check everything. Where do I have Light LLM, right? So you need to be able to answer that question. Because again, if you don't know what you have, you cannot possibly secure it.
I think for me, it would be about ensuring that no AI code directly goes into production with appropriate review controls, right? I mean, people really want to get things out fast and compete in the AI market. Everybody wants to say that we got an app out in 2 days, a week's time. So that raises crazy, but just add your right controls, have proper reviews before getting into production, at least a human review before getting into production, right? Don't directly push AI code into production. And the second one is the development and engineering teams, I think, are way ahead of the game. So talk to them and develop your AI governance policies. There are times that you probably don't even know that what they're plugging in into their IDE to make their lives better. So it's important to understand what solves their problem and then work with them to solve it together. Just don't solve it as a single security team alone.
And last
For
word.
me, it's more difficult because the good things are already taken. But yes, I completely agree. The first of all is the AI inventory is the first step. Absolutely. Can sound hard to have it because it's difficult to review everything and to detect or to discover all the assets in all the places and that. But it's something that is mandatory to do. Okay. The other thing that we have introduced that you can start doing tomorrow is a best practice is use different identities, provide the specific permissions for your agents. Don't share the developer permissions, the developer environments, isolate a bit the agents independently if you can track or not, but put the scope, provide the specific permissions for that part. Okay. I think this is the two more important things. And just to put something new, set for something like dependency firewall, something like that, to block installation in the endpoint automatically, at least the known vulnerabilities or something that can detect if something is malicious or not, and block that entry point. Okay, then you can improve and control more things, but these are the main way of attacking today. And if you can stop it proactively and you can block this point of the main way of attacking the agents, you have a very good starting point.
Okay, great. I think we are mostly out of time, but we have 5 minutes. I will abuse your time. 5 minutes for some questions, and we have I think we have one question here. This one. Probably this is a bit complex. He's talking about how to get now that the agentic AI is generating a lot of new code. The bottlenecks that we have with the standard, the all times operational checks, security checks. And he's talking about the harness engineering layer. Maybe you can say something about this, Xygeni?
Yeah, so I think the first step is to do your basics right? So when we are talking about AI, everybody's talking about these AI scanners that look at the code first. I think take a step back and do your threat modeling right? So have that foundation right. And once we've had that, then when we get into the next stage of code, I think it's about aligning that if your code's actually matching your design intentions, right? So if the implementation, if the build is catching up with that, if there's an alignment with that, then your SAST also has to align to that. So I think there's a mismatch between how we do SAST. We just run something on the code and say, okay, it's there, these are the issues, fix it, but we don't tie it back to the foundational activity. I think that becomes important. And yes, again, anything related to harness engineering in terms of what we can build as guardrails around a constraints MD file that can be fed into any of these agents is important again. So I think these are the two things that I would say would become important in a multi-agentic pipeline for development. These are the two that I can right away think of. But yeah, and about the skills catalog, right? Yeah, the first time I saw skills and one of our developers pulling it in, I was like, oh my God, this reminds me of GitHub Actions, right? People would just pick it up from Marketplace and start using it. And even GitHub themselves didn't give you a specific guardrail to protect it. And there were so many controls missing out there. And I was like, oh God, this is such a big supply chain attack itself. So I think the best thing we can do with skills is like build a catalog internally and say only pull from these approved repos and don't pull the skills outside. As of now, I don't see a technical solution to prevent from pulling out skills, I guess. But at an IDE level, it's really difficult to implement such technical controls. But I think at a governance level, there's something that we can really do. But I would be happy to learn if somebody has already been ahead of the curve and implemented a technical control for skills. That would be interesting.
Well, my suggestion be going back to skills, Ashwini, is to look into implementing a, let's say, organization-wide skills marketplace, and that's kind of a technical control, and that is the marketplace where skills can actually be properly governed and security scanned and validated. This is where security by design can be implemented, because there are a lot of hidden dangers in agentic skills. And for those of you who are not aware, there is a brand new OWASP project for this, and this is OWASP Agentic Skills Top 10, which is currently in development. So I invite you all to check it out. And I think you will learn a lot. There's a team which is currently working, and if you have something to contribute, don't forget that all OWASP projects are open source. And if you have some knowledge or expertise that you want to contribute to OWASP, you're always welcome.
We have time for another question.
Yes, sorry, Luis, there's one thing.
Yeah, Jesus.
The question mentioned that the post-commit control, okay? The idea is don't wait until the post-commit. Don't wait until the pipeline or the CI/CD. Put everything integrated in real time. At the same time, you generate the code, analyze the dust is not possible, but analyze SAST, analyze SCA, and analyze secret detection, because the sample that Sam mentioned at the beginning is really happening a lot of time. So control at least these three things during the generation moment, in real time, everything combined, before doing any commit, before doing any finished process of the code generation.
Okay, we have time for one more question. This is the typical wars between dev and SecOps.
Yeah, that goes to the old, rainbow unicorns memes and security people just shoving the security issues across the fence. I think it's security is everyone's responsibility. That would be my answer. So I think it's a collaboration. So security people need to work with together with developers and with the management to address this. But simply by for developers to say I'm not responsible for security, that's why I'm not doing it, I think would be incorrect.
I think maybe
I like the question.
maybe I've been developer for a lot of time. I think that to solve anything, you need to understand what you are building, the logic behind, and you need some context about the functionality and this kind of thing. So I think it's going to be difficult for someone that is not involved in the development solve anything, even with the support of the AI or whatever.
Okay, we have time for a last question. Oh, we are vendors. We inside Xygeni, we are vendors of SAST, so maybe we can.
No, I think I can take
our...
this. So, I mean, we did try using Claude for scanning and all of those things, right? It's pretty expensive. You just can't put in multi-repos inside there and say, scan it all for me. It's pretty expensive. And as a company, you need to be aware, or even as a leader, you need to be aware of how much you're spending on what aspects. Cost has always been a limitation, even for security, right? Getting some budgets approved for fixing or even hiring people has been a concern. So in that aspect, I would say, code scanning with AI is super expensive. when you're talking about complex code systems. And also at times it can be pretty generic and hallucinate. It cannot. It's very difficult for you to give that very specific context analysis without hallucination, right? So that we've seen that I'm speaking based on my experience. So I think a combination of AI versus plus a SaaS tool is a great combo. It's about how you strategize and use AI plus SaaS, where you use SaaS and where you use AI. I think that's a good strategy you can do for your own code base based on what works best for your application and take it forward. There's no either this or that. I think it's the best of both worlds that we'll have to look at.
Yeah, I agree. Because we have analyzed also this approach, and beyond the cost that is really expensive, order of magnitude more expensive. There are other 2 points. That is even very difficult to have the same result doing the analysis of the same code. Is going to generate probably different results every time that you execute something, because it's not deterministic. So it's going to be difficult to replicate and to have something that is confident or something that you can trust. And the other part is it takes a lot of time to do this analysis. It needs a lot of time to finish analysis. So it's very difficult to integrate in a continuous integration pipeline or something like that, because it's going to introduce a very big delay in the process of the build or the artifact and this kind of things. I agree with Srini. The best approach is combine both worlds. Use the AI very strategically for specific things, refine for something that is more semantic, or to analyze context and this kind of things. But I think the combination is the best approach.
Okay, so I think the time is over. A big thank you to Sam Estepanian, Srini Sidhi, and Jesus Cuadrado for sharing their time and insight today. And thank you to everyone in the audience for being here live. To keep digging into this, check the OWASP GenAI security project, which is an excellent reference. And see you at OWASP Global AppSec in Vienna this June. I think it's 2 weeks' time. So thank you for joining SafeDev Talk. Stay curious, stay safe, and see you in the next session. Bye.
Thank you very much. Bye.
Thank you.